Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam, February-March 2024, paper 42. Let's start it. Question 1. Iron ore contain iron 3 oxide. A blast furnace is used to extract iron from iron oxide. Equations for some reactions in the blast furnace are shown. As we can see, here we have three equations representing some of the reactions in the blast furnace. Equation 1 shows combustion of carbon in the blast furnace. Carbon reacts with oxygen to form carbon dioxide. This is a combustion reaction. Names the substance which provide the carbon for this reaction. The raw material which is added to the blast furnace to provide carbon is coke. State the purpose of the combustion of carbon in the blast furnace. Of course, carbon provide heat or increase the temperature inside the blast furnace. Iron 3 oxide in the iron ore is converted to iron by reaction with carbon monoxide. Calculate the percentage by mass of iron 3 oxide of iron in iron 3 oxide. To calculate the percentage by mass iron, we have to know the mass of iron in the formula, and we will divide it by the total mass of the formula, then times 100. The total mass of the formula is calculated by, we have two iron ions, so each has a mass of 56. This is the total mass of iron. Then we will multiply the mass of oxygen by 3 because we have 3 oxygen. The total mass of iron oxide will be 160 and the mass of iron is 112. So the percentage by mass iron is 112 divide 160 times 100, it is 70%. State the name of the iron ore which contain mainly iron oxide. The iron ore is hematite. Describe how carbon monoxide is formed in the blast furnace. Carbon monoxide, as we can see here from the equation, it is shown by the reaction of carbon dioxide with carbon. So when carbon dioxide is reduced by carbon, it will form carbon monoxide. Our answer will be carbon monoxide is formed by the reduction of carbon dioxide by carbon. Write a simple equation to show the reaction when iron 3 oxide is converted to iron. Here, the iron 3 oxide react with carbon monoxide to form iron and carbon dioxide. Remember, the equation is for 2 marks, so we have to balance the equation. Name the chemical process which happened to iron 3 oxide, which is when it is converted to iron. As we can see here, iron 3 oxide loses oxygen to convert to iron, so the process is reduction. State the type of reaction shown by equation 2. In equation 2, we can see that calcium carbonate is broken down into calcium oxide and carbon dioxide. This broken down by heat is called thermal decomposition. So the type of chemical reaction shown by this equation is thermal decomposition. Explain why the reaction in equation 3 can be described as an acid-base reaction. Here in equation 3, we have calcium oxide, which is basic oxide because it is a metal oxide, and silicon dioxide is acidic oxide because it is non-metal oxide. So it is a reaction between acidic oxide and basic oxide, can be described as acid-base reaction. State the chemical name for silicon dioxide. The chemical name is silicon 4 oxide. The common name given to the calcium silicate when it is formed in the blast furnace. The common name, like the commercial name, is slag. Aluminium cannot be extracted from its ore using a blast furnace. State why aluminium is not extracted using a blast furnace. Because aluminium is more reactive than carbon, or we can say aluminium is above carbon in the reactivity series, so aluminium oxide cannot be reduced by carbon. That's why aluminium cannot be extracted in the blast furnace. Name the process used to extract aluminium from its ore. We can extract aluminium by electrolysis. Both iron 3 oxide and aluminium oxide contain a metal ion with a charge +3. Write the electronic configuration of an aluminium ion. Let's refer to the periodic table. We can see the atomic number for aluminium is 13. So the electronic configuration of aluminium will be 2, 8, 3. to form an ion with the charge +3. Aluminium lose these 3 electrons, so the electronic configuration will be only 2, 8. Deduce the number of protons and electrons in the iron. Again, referring to the periodic table, the atomic number for iron is 26, so the number of protons in iron is 26, and because it has +3 charge, that means it loses 3 electrons, so the number of electrons will be less than the number of protons by 3, so we will have 23 electrons. Question 2. Elements of group 7 in the periodic table are known as halogen. Halogen can form halide ions. Identify the halogen with the lowest density at room temperature and pressure. As we know the trend for group 7 density, the density increases as we go down the group. So the element of the lowest density will be at the top of the group, so it is fluorine. State the appearance of bromine at room temperature and pressure. Bromine is a reddish brown liquid. Use the periodic table to give the symbol of the halogen with the highest atomic number. As we know, the atomic number increases as we go down the group, so we will go to the periodic table to check the last element in group 7 will have the highest atomic number. Here in the periodic table, giving in this exam, the last element is tennessine and the symbol is TS. Deduce the number of occupied electron shells. The number of shells equal to the number of the period. Checking the number of the period for tennessine, it's period 7. Bromine molecules have covalent bonding. State what is meant by the term covalent bond. Covalent bond is a bond formed by sharing one or more pairs of electrons between 2 atoms. Halide ions. Name one halide ion which bromine molecule can displace. Take care, he's asking about the ion, so we have to write the name of the ion. One halide ion which bromine can displace, that means it is less reactive, the element less reactive than bromine, so the halide ion can be displaced as the iodide ion. Explain why bromine can displace this halide ion. In question II, bromine is more reactive than iodine. Take care here when you write iodine and iodide. Iodide is the ion and iodine is the diatomic molecule, which is the element. So don't confuse between iodide and iodine. Name the halide compound which can be used to detect the presence of water. We can detect the presence of water using anhydrous cobalt 2 chloride. The color change from blue to pink indicates the presence of water. Calcium chloride is an ionic compound. Complete the dot and cross diagram for the ions in the calcium chloride. The electronic configuration for chloride ion is 2, 8, 8. First, the chlorine atom has electronic configuration of 287 and it gained 1 electron from calcium. Now it has 288, 7 dots and 1 cross because this electron comes from calcium, and now we have 1 negative charge. This will be the same for the other chloride ion. 7 dots in the outer shell and 1 cross represent electron that comes from calcium atom, and again we will have 1 negative charge. For calcium, the calcium atom has electronic configuration of 2, 8, 8, 2. It loses these 2 electrons, 1 for each chloride ion. Now the electronic configuration for the calcium ion will be only 2, 8, 8, and we will have charge of +2 because it loses 2 electrons. Aqueous lead ions are added to aqueous chloride ions. A white precipitate of the insoluble lead chloride is formed. So we want to add aqueous lead ions to aqueous chloride ions. Name the lead compound which can be used in this reaction. We want a lead compound that can provide aqueous lead ions, so we need a soluble lead compound. We will choose lead nitrate because we know that all nitrates are soluble. Write the ionic equation for the reaction, including state symbols. The ionic equation includes aqueous lead ions plus aqueous chloride ions produce the insoluble, which is solid, lead chloride. Here we have 3 marks for the 1 mark for this state sample, 1 mark for the correct charges, and of course 1 mark for the balance of the equation. Name one other insoluble chloride. Silver chloride is insoluble. Question 3. This question is about acids, bases, and alkalis. This table shows some pH values for some substance: sodium hydroxide, calcium hydroxide, water, ethanoic acid, and nitric acid. As we can see, the pH for each substance. Define the term base. Base, of course, is a proton acceptor. State what is meant by the term alkali. Alkali is a soluble base. When the base dissolves in water, it will form a solution. This solution is called alkali. So alkali is a soluble base. Thymolphthalene is an indicator. State the color of thymolphthalene in sodium hydroxide. Thymolphthalene gives blue color in sodium hydroxide, and in ethanoic acid, thymolphthalene will be colorless. Use the information in the table to identify substances with only one substance with the highest concentration of H ions. The substance with the highest concentration of H ion, of course, will have the lowest pH. So let's check the table. The substance with the lowest pH is nitric acid. So nitric acid is a substance with the highest concentration of proton because it has the lowest pH. Name an indicator which can be used to identify the substance with the highest concentration of proton. We can use the universal indicator. As we can know, the universal indicator gives wide range of color depending on the pH. So we can use the universal indicator to identify nitric acid because it will give a darker red color with nitric acid. Of course, it will give an orange color with ethanoic acid. So because it gives different colors according to the pH, it can be used to identify the substance with the high proton concentration. Complete the equation to show the dissociation of ethanoic acid in aqueous solution. Ethanoic acid is a weak acid, so the dissociation is reversible. We have to draw the reversible arrows. Then the negative ion will be the ethanoate ions, the H3COO, and the positive ion, of course, it will be the proton. Here the equation is for 3 marks. 1 mark for the correct formula of the ion, 1 mark for the charges, and the 3rd mark is, of course, for the reversible arrows. So you have to know that the dissociation equation for the weak acid must be reversible. Write ionic equation for the neutralization reaction between any acid and any alkali. The ionic equation for the reaction between any acid and any alkali will be reaction between protons plus OH ions to give water. As we can see here, the equation between sodium hydroxide and hydrochloric acid to form sodium chloride and water by removing the spectator ions which didn't take part in the reaction and remains in aqueous state with the same charge. Sodium ion, we will remove sodium ion. Chloride ion, because it has the same charge in the product also, it didn't change, so only we will have OH ions plus proton to form water. This is the ionic equation for all the reaction between acids and alkali. Dilute nitric acid react with aqueous calcium hydroxide as shown in the equation. We have 20 centimeter cube 0.015 mole per decimeter cube calcium hydroxide react with 25 centimeter cube of nitric acid. Calculate the concentration of nitric acid in gram per decimeter cube. First, we will calculate the number of moles of calcium hydroxide because calcium hydroxide is aqueous solution. So to calculate the number of moles, we will multiply the volume in decimeter cube by the concentration. First, to convert the volume into decimeter cube, we will divide 20 centimeter by 1000. then we will multiply by the concentration, which is 0.015. So the number of moles of calcium hydroxide will be 0.0003. Then, to know the number of moles of nitric acid which will react with calcium hydroxide, we can deduce it from the equation. The ratio between the number of moles of nitric acid to calcium hydroxide is 2 to 1. That means number of moles of nitric acid is double the number of moles of calcium hydroxide. So we can simply multiply the number of moles of calcium hydroxide by 2, and the number of moles of nitric acid would be 0.0006. The concentration of nitric acid in mole per decimeter cube first. To calculate the concentration, number of moles equal to the concentration times the volume in decimeter cube. So the concentration will be the number of moles divide the volume will be 0.024 mole per decimeter cube. Then we want to convert the concentration from mole per decimeter cube into gram per decimeter cube. This will happen by multiplying by the MR of nitric acid. So the MR of nitric acid will be 1 plus 1 for hydrogen, 14 for nitrogen, and 48 for oxygen, 16 times 3. So the mass of nitric acid will be 63, and the concentration will be 0.024 times the relative formula mass of nitric acid, which is 63. So the concentration will be 1.512 gram per decimeter cube. Question 4. The equation for the reaction between methanoic acid and ethanol in the presence of catalyst can be represented as shown, where X is the ester formed. In the equation, methanoic acid is represented by the formula HCOOH. Name this type of formula. This formula is called structural formula. Write the empirical formula for methanoic acid. To write the empirical formula, first we have to write the molecular formula, which is the total number of each type of atom present in the formula. So we have 1 carbon, 2 hydrogens, and 2 oxygen. This formula cannot be simplified anymore, so the empirical formula is the same as the molecular formula. It will be CH2O2. Name and draw the displayed formula for ester X. Ester X is formed for the reaction between methanoic acid and ethanol, so ester X will be ethyl methanoate. So to draw the displayed formula for ethyl methanoate, first we will draw the ester linkage, and because the acid is methanoate, so we only have 1 carbon, so only here we will add 1 hydrogen. This is the methanoic acid part. And for the ethyl, we have to draw the ethyl group, which is CH2CH3. So this is the formula of ethyl methanoate. The reaction is reversible and reaches equilibrium within a closed system. State what is meant by the term closed system. Closed system is a system where nothing can enter or leave from the system. State 2 characteristics of an equilibrium. The 2 properties or characteristic of equilibrium, that the rate of the forward reaction is equal to the rate of the backward reaction, and the concentration of the reactants and the product are constant. Complete the table to show the effect of any on the concentration of ester X at equilibrium for each change of the condition. First, the change is decreasing the temperature. The reaction is exothermic, as we can see if we have negative delta H. So by decreasing the temperature, the equilibrium will be shifted forward. That means formation of more ester, so the concentration of ester will increase. Concentration of methanoic acid decrease. If we decrease the concentration of methanoic acid, the equilibrium will be shifted backward to produce more of methanoic acid, so the concentration of ester will decrease. The third change, concentration of both methanoic acid and ethanol will decrease. Again, the equilibrium will be shifted backward to produce more product, so the concentration of ester will decrease. If the catalyst is removed, we will have no effect on the concentration of ester because catalyst has no effect on the concentration or the amount of the product. Catalyst will only increase the rate of the forward and the backward reaction and has no effect on the equilibrium yield or equilibrium concentration. Question 5. Butane and but1-ene are colorless gases at room temperature and pressure. Suggest why but1-ene diffuses quicker than butane. By calculating the molecular mass for both butane and but1-ene, we will find that but1-ene has a lower molecular mass. That means it will diffuse faster or quicker than butane. Identify the products formed when butane undergoes complete combustion. We know that complete combustion only produces carbon dioxide and water. One molecule of butane reacts with one molecule of chlorine in the presence of ultraviolet light. During the reaction, only one hydrogen atom in butane is replaced by chlorine atom. Name the type of reaction needs ultraviolet light. Of course, it is a photochemical reaction. State the purpose of ultraviolet light during this reaction. Ultraviolet light provides the activation energy needed for the reaction. Name the type of reaction which takes place when one atom of chlorine replaces one atom of hydrogen. This replacement is called substitution reaction. Butane is alkane, so it reacts with halogen in a substitution reaction. How many different structural isomers can be formed during this reaction? As it is mentioned here, only one hydrogen atom is replaced by chlorine, so we can have only two isomers. The first isomer is 1-chlorobutane and the second isomer is 2-chlorobutane. So these are the two isomers can be obtained from the reaction of chlorine with butane. When but1-ene reacts with steam, two possible products formed. Identify the type of catalyst which is used in this reaction. But1-ene is an alkene. It reacts with steam to produce one product which is alcohol. We know that the condition needed for this reaction include a catalyst which is phosphoric acid. Here he is asking about the type of catalyst, so the type of catalyst will be just acid. Because he's not asking for the name of the catalyst, he's asking for the type of the catalyst. Two products are formed, which is two isomers for the alcohol, but the catalyst needed is acid. Name and draw the displayed formula of the two possible products formed when but1-ene react with steam. Let's draw the equation for the reaction. 1, 2, 3, 4, it is butene, but1-ene. So when but1-ene react with steam, we will have water added on the double bond. And we can have two possible products. Of the OH added on this carbon, we will have butane 1-ol. And if the OH is added on this carbon, we will have butane 2-ol. So these are the two possible products formed. This is the butane 1-ol. This will be butane 1-ol. And if the OH is added on the other carbon, so we will have butane 2-ol. If the OH is added here, again we will complete the hydrogens. So we have two different isomers for the alcohol formed, butane 1-ol or butane 2-ol. We have the isomers here, the displayed formula for the isomers. Here we have butane 1-ol, the OH is added on the first carbon, and butane 2-ol if the OH is added on the second carbon. And here we have the displayed formula of the two possible isomers or products. But1-ene undergoes polymerization. State the type of polymerization when but1-ene undergoes. Of course, but1-ene is an alkene. It contains double bonds, so the polymerization will be addition polymerization. Draw part of the polymer molecule to show 3 repeat units. To draw the polymer, we will first have to know the first repeat unit, or how to draw one repeat unit. The repetition, of course, will be on the double bond. So the two carbons will make the repetition. We will draw carbon 1 and carbon 2. Okay, the first carbon have 2 hydrogens. We will draw the 2 hydrogens. Then the second carbon contain 2 branches or 2 substituents. So the first one is hydrogen and the second one is ethyl group, C2H5 or CH2CH3. So this is the second carbon. Now I have drawn the first repeat unit, contain carbon that originally have the double bond. The first carbon have 2 hydrogen and the second carbon have 1 hydrogen and 1 ethyl group. This is the first unit, and then we have to repeat it, drawing the second repeat unit and the third repeat unit. Then don't forget to draw the open end, represent the continuation of the isomer. This is how to draw 3 repeat units of the polymer. Now we come to the end of our exam. Comment down below if you have any question. Like the video and subscribe to the channel to receive the updates. Thank you for watching and wish you all best of luck.